Hi, welcome back to Null Zero Labs. Now, in our third episode of our BGP Freecore here, we are going to add a VPLS service for a third customer on our core network here. We're going to be adding a customer that at first will require a VPLS service to connect 3 locations. So we're going to create a bridge domain and a layer 2 service for this customer, but we're going to use VPLS so that we can have that customer's subnet and VLAN spanned across 3 locations, and we're going to test that. And then we're going to test how you could also use VPLS in a rooted fashion so that as the customer, you can maintain complete control over your routing of your WAN service without having to pass any of those routes to your service provider. So this is the lab now that I have added 1, 2, 3. So this is our VPLS customer 1. They've got a site 1, a site 2, and a site 3. They're going to be connecting a single switch in each one of these locations. They're going to be connecting in on, we're going to put this as tagged VLAN 200, and they're going to put a, SVI interface on each one of these switches and check that we have full reachability for the same subnet across 3 locations. So this would be useful if you wanted to keep the same network accessible in all 3 of these locations and have VLAN 200 over here, here, and here, and have all the machines talking to one another as if they were all connected to a single switch. Once we've got that working and verified, like I said, we're then going to swap out these switches for routers, and then the customer is going to create their own routed network, and they're going to use OSPF to share the routes that their routers are sharing between the 3 sites. And you'll see how, from the ISP perspective, we then don't have to deal with those routes like how we did, say, with our first customer here, who's a layer 3 customer. And we obviously had to configure the ability to import those routes that the customer was advertising to us. We then had to advertise them across, remember, using VPN4, multi-protocol BGP. Likewise, this customer could do it as well, similarly, because this one was the customer that we did with an L2 L2 VPN again, and it's done using L2 VPN EVPN. Now we're going to do it using L2 VPN VPLS. So we're going to use yet another protocol, and we're also going to make use of our multi-protocol BGP experience that we've learned so far by using the BGP for BGP VPLS signaling rather than using the LDP signaling feature where we would have to manually say this PE is member, this PE, this PE. So we're going to use BGP to signal that it has knowledge of one of these VPLS VPNs, and it will advertise that to the other members. So let's jump into the CLI. Let's start getting our PEs configured. So here we are on PE4, and we're going to start on PE4 because this is our VPLS customer 1 site 1's location. They're going to be connected to interface G4, and we are going to create a VPLS BGP peering from PE4 to PE3 where they've got site 2. We're also going to make one over to PE2 where they've got their third site. And then likewise, when we do PE3, it will have a peering over to PE4 and to PE2. And PE2 will have a peering to PE3 and to PE4. So we're going to create a full mesh of BGP peering for our VPLS nodes. And we're going to configure that it uses the BGP signaling to say, hey, I'm a member of that VPLS VPN. You can share information with me. So let's start on PE4. So as usual, config T. Now what we're going to do is we're going to start with a bridge domain again. We remember we used that when we did our layer 2 service using eVPN. So we're going to start with our bridge domain. So bridge domain. Going to give it an ID. I think last time we used 100, so this time we'll just use 1,000. And then we're going to assign a member interface, and the first member interface we're going to assign is going to be our gigabit 4, the one that's going towards the customer, and we'll assign that's going to come in on service instance 1000. Okay, we're also going to add this into we'll come back to that. So that's that. Let's configure the interface so that we know that it's configured. So int g4, no IP address, no CDP enable as it's towards a customer. And what we will do is we will do our service instance 1000 Ethernet, and we're going to encapsulate that with .1q VLAN 200. So that's what we're expecting the customer to send to us, is traffic that is tagged as VLAN 200. We'll exit that and we will no shut the interface. Next, we'll create our L2 VPN, and this time we're going to create a VIF, a virtual forwarding instance. So a VIF, and it's going to want a name. So we're going to call this VIF1 just for simplicity. So that is similar to, we could say that this is going to be similar to like how we created our VRF. So this is a similar scenario. We're creating a virtual forwarding instance. We're going to give it a VPN ID, and we'll call this 1000 just so we can keep everything consistent. And then we're going to say auto discovery BGP signaling BGP. So we are going to use BGP signaling to say that we are advertising this this VPN. We're then going to give this device an ID. So this device, as it's the first one, we'll call this 1000, and the V range will be 11. It has to be above 10, so we'll just use 11. So that should be it for our virtual forwarding instance. Let's go back into our bridge domain. So our bridge domain 1000, and we will add another member, which will be that VI instance. So we will add a VIF, VFI. I'm typing the wrong one. So we want to add a VFI, and it was VFI1. That's the one I'm looking for. All right, so now if we do a do show run and we double check. Yeah, so there we go. You can see we've now created a similar bridge domain as we did for our EVPN L2 service. But you can see we've created a similar service and we've added our VFI interface to that, our virtual forwarding instance to the bridge domain. So now that we have that, let's go and configure the BGP part. Okay, now we're going to need a full mesh. So we are going to peer over to, what's this one's loop back address again? Let's move that there so we can see it. So we're going to peer from .7 to .6 and to .5. So neighbor 1.1.1.6, remote AS is 65000. Our update source is going to be our loopback. The next neighbor is .9. And again, our update source for .9 is going to be our loopback. Now we're going to go into our address family again, because remember we're using multi-protocol BGP. So our address family, it's going to be L2 VPN, but this time we're going to use VPLS. So VPLS. And then our neighbor 1.1.1.6, we're going to activate. We are going to send community both, and we are going to suppress our LDP protocol because we're going to use BGP signaling. Next, we will do the same for our other PE, which was .5. .1.1.1.5. I've done the wrong neighbor up here. We'll fix that. Okay. So exit that address family quickly. No neighbor 1.1.1.9. Neighbor 1.1.1.5. Remote AS is 65000. Our update source is L0. Now back into the address family, L2 VPN, VPLS, and our neighbor, activate, send community both, and we will suppress LDP. Save that. Let's have a quick check of what we've configured. So show run. So again, we've configured our L2 VPN context. This time we've created a virtual forwarding instance. We've given it a VPN ID of 1000. We've given this device an ID of 1000, and we've set up our BGP signaling. We have then created our new bridge domain of 1000. We've assigned the interface towards the customer, and we've assigned the virtual forwarding instance, this time, virtual forwarding instance, not the VIF, the virtual forwarding instance as part of that bridge domain. And then down on the interface towards the customer, we have configured the interface towards the customer and assigned it to that service instance and said that we expect it to be encapsulated with VLAN 200. Under our BGP, you can see that we have added our neighbors 1.1.1.5, 1.1.1.6, so 5 and 6, these two PEs. We've got our, not only have we got our EVPN service configured under here for our other customer, we have added our L2 VPN VPLS configuration between the nodes that we expect to be sharing information with. So that's created. So that should be it for PE4. Let's jump onto our second one, which will be this one over here, PE3. And we're going to do a very similar configuration. So let's jump on to PE3. If I can remember the password. There we go. Config T. Now we'll start with the same. Let's do our bridge domain. So bridge domain 1000. Member is going to be, again, G4. So gigabit Ethernet 4. And we'll bind that to a service instance of 1000 as well. We will come back and add the other instance after we do our L2 VPN context. So let's do that. So our L2 VPN, and we're going to create a VFI context, and we're going to call this VFI1. Remember, this is local. This is a local device, local context to the router, so it doesn't have to be the same as, doesn't have to be named the same as PE4, but obviously it's helpful if it is. The VPN ID, that must match. That was 1000. Auto discovery, BGP. signaling is BGP, because we are going to use our multi-protocol BGP, following along with the theme of our 3 videos so far. So that's done, and then we're going to set our our device ID. So this is the PE's ID. So over here on PE4 we used 1000. So this has to be unique across the domain. So let's do this one as 1001. And our VE range will be 11. That also has to match across the whole config. So that's that. Let's jump back into our bridge domain again, 1000, and let's add a member, our virtual forwarding instance, and that's VFI1. So now let's jump onto our interface towards the customer. So int G4. And that will no shut that interface, and that is going to be our service instance 1000 Ethernet. We're going to encapsulate that with .1Q, and we expect VLAN 200. Now router BGP. Now we're going to have a neighbor relationship with 1.1.1.7. The remote AS is 65000, obviously, it's iBGP. We're going to update using our loopback address. And we're also going to peer with PE2, so neighbor 1.1.1.5, remote AS 65123. And our update source again is going to be our loopback. Now our address family is L2 VPN. Again, we're using VPLS. So neighbor 1.1.1.7, we're going to activate our service to there. We're going to send community both, and we're going to suppress the signaling of LDP because we are using BGP for signaling. Next, neighbor is going to be 1.1.1.5. Activate, send community both, and suppress LDP signaling. So let's save that. Let's show run. So we've created our VPLS context, VPN ID 1000. This is device 1001, and we're using BGP signaling. We have created our bridge domain 1000. We've assigned the interface towards the customer, and we've assigned the VFI as part of that bridge domain also. We've configured our interface towards the customer, that it's part of service instance 1000, and we expect traffic to be tagged with VLAN 200. We have then added our neighbors within our BGP config on PE3. So over to .7, PE4, and over to .5, PE2. We have then added our L2 VPN VPLS address family. And we have said, yep, you can activate services to both of these PEs, and to suppress signaling via LDP and use BGP signaling. So that should be it for PE3. Finally, let's do PE2. So I'm going to jump on a PE2 again. Again, you learn by repetition. So we're going to create our bridge domain of 1000. Our member is going to be gigabit 4, assigned to service instance 1000. We're going to create our L2 VPN We're going to create a virtual forwarding instance. Virtual forwarding instance. And we're going to call this VFI1. We're going to give this a VPN ID of 1000. Our auto discovery, we're using BGP, signaling BGP. Our device ID, our virtual edge device ID is the other one. This was 1000. This was 1001. This will be 1002. And then our, what was our VE range 11. And now if we jump back into our bridge domain, 1000, member virtual forwarding instance, VFI 1. Let's add our interface to the customer. So int G4, no shut, and this will be service instance 1000 Ethernet, and we'll encapsulate that with .1Q200. Now finally, a router BGP 65000. So neighbor 1.1.1.6, remote AS 65000. Our update source will be L0. We'll also have a neighbor relationship to 1.1.1.7. Again, remote AS 65000. And the update source will be L0. Address family, layer 2 VPN, VPLS. Neighbor, 1.1.1.6. Activate, send community both, and suppress LDP signaling. Next, neighbor 1.1.1.7. Activate, send community both, and suppress signaling. Let's save that. Let's double check our work. So show run. Now we can see this side we're using a layer 3 VPN service for this customer AS100. So we've got that. Here we can see we've got our VPLS customer. The device ID is 1002, part of VPN 1000 using BGP signaling. So we have our bridge domain with our Ethernet towards the customer. Our VFI is there. We've configured our interface towards our customer, GE4. I'll put a description on that as well. So GE4. What's G? We're on P2, so G4. Oh, why have we got G3 in there? Okay. G4 is configured towards our customer. Under our BGP, we have peerings to our required PEs. We have our, under this one, we've got a layer 3 customer, and they're receiving their routes in via this VRF. We also have our VPLS customer configuration to share between our other routers here under BGP. So that should be all of our configuration for our PE devices. So what we can do now is let's do some verifications to see that all of the signaling and the VFIs, etc., are up. And then we'll test from each of these switches. I'll show you on the switch how we've configured interface E1 to be a trunk port, and we've assigned VLAN 200, and we've created an SVI in VLAN 200 and given it an IP address. And then that will check our reachability across our VPLS service. So let's look at PE4. I'm really starting to hate this keyboard. Let's do a show bridge domain 1000. So we can see we've got our bridge domain up on PE4. So we can see it's up. MAC address learning is enabled. We can see the interface towards the customer is part of that bridge domain. And we can see that these pseudo tunnels that have been created between our PE devices, because they've signaled that they're part of this bridge domain, have also been added. So whereas before we only added a single VFI, when we added the member under the bridge domain, we said member VFI, VFI1, we can see that these other neighbors are part of VFI1, and they have signaled that, and they are part of it as well. So we can see PE4 can see PE3 and PE2. Let's just do that across all of them, just to make sure that's all working. So show bridge domain 1000. Again, correct. Interface towards the customer. We can see PE4 has signaled it's part of the bridge domain, and we can see that PE2 has also signaled that it's part of the bridge domain. Show bridge domain 1000 on PE2. Slightly different output because it's a different router. This one's a CSR. So we can see, again, the same information is near enough there. 3 ports are in the group. It is up. We can see interface towards the customer and a pseudo tunnel from PE2 to PE4 and to PE3. Okay, so back to PE4. Let's do a show L2 VPN VFI. And there we can see similar output, but again, we can see the VPN ID. So the VPN ID across all 3 of the PEs is 1000. We can see that this device is 1000. We can see that it's automatically added our route distinguisher and our route target. And we can see that the bridge domain is attached, and we can see the local pseudo wire interface and the pseudo wires that go over to VEID 101 and VDID 102. So that's PE3 and PE2. Show MPLS where's the command I'm looking for again? MPLS L2 VC. So again, we can see our virtual forwarding instances. The local interfaces are up, and the destination locations to PE3 and PE2 status up. So that is all functional. Let's just do one other test. Show BGP L2 VPN VPLS all. So we can see information has been exchanged from ID 101, 102. So we can see information is being advertised and signaled from both of our PEs to PE4. Right, so let's jump onto our switch. So switch 1, switch 2, and switch 3. Now, show run. So each switch has got a VLAN of VLAN 200. We have created our interface towards our PE. as a trunk, and we've allowed VLAN 200. We will put all of these switch ports into switch port mode access, VLAN 200, add our devices, do the same on all of our switches. They will be able to see each other. But for this testing instance, I've added just an SVI instance on each one of these switches. So this one is .1, this one is .2, this one is .3, and we can ping between them. So we will send a ping 192.168.64.2, and you can see that we can reach from this broadcast domain over to the same broadcast domain over here on different part of the country, coming out of a different PE. We can do the same if we ping to 3. We're connected to this switch on PE2, but all 3 of these switches appear within the same broadcast domain. Likewise, if we jump onto one of the other ones, so if we ping 192.168.64.1, we can see that we can reach over to .1, and we can again reach over to .3. If we jump back to our PEs again, and we look at our commands, I'm trying to find the one, just show you the MAC address table. Show L2, I think the best one is show bridge domain. That will show it, show bridge domain. So if we look at the bridge domain, we can now see the MAC addresses for each of those devices and where they're coming from. So we go and have a look. So that one there, gig 4, so PE4, it said this MAC address is coming from interface G4. So if we have a look at our switch, VLAN, show int VLAN 200, and the MAC address for this SVI ends AC19. We have a look, AC19. So there we go. So that MAC address for that device has been populated into the bridge domain table on PE4. And then if we look, this one here has been assigned a label and a VPS. So it's going down a tunnel across the network to the corresponding PE. So this one will, if this PE receives a packet saying, hey, I'm destined for this MAC address from this switch, it's going to then forward it across our MPLS core over to the PE and out to the correct switch that is required. So if we look at this one is EF21. So let's go and have a look on, let's have a look at switch 2. Show int VLAN 200. That's 40C. Let's have a look at version 3. Show in VLAN 200. EF21, so switch 3, that's this one here. So if we look at PE2, we do a show bridge domain 1000. We can see, there we go, EF21, it's got to come out of G4 to reach the switch. So when it's going from PE4, so switch 1, goes up to PE4, it goes, hey, I need to reach this MAC address. It then switches it across our MPLS core over to PE2. PE2 looks at its table within the bridge domain and it goes, hey, that MAC address is available via gig Ethernet 4, and it sends it down to the corresponding switch. Next, what if the customer wanted to swap these devices, instead of them being switches, with routers, and they wanted to have a routed network between all 3 of these sites rather than a bridged layer 2 Ethernet domain? Well, they can do that. So let's delete all of these switches or move them to the side, and I will add a router to each one of these, and then we will configure an interface on each one of these routers. We'll configure a inside interface, and we'll set up OSPF for that customer where they can advertise those inside interfaces to each other, and we can test that traveling across our our core network as well. But this time, we won't have to receive any routes from the customer and then re-advertise them to the peers. The customer can have complete control over their own routing environment. So let's swap that around now. Right, now as you can see, I've changed the topology again. This time now the customer has decided to remove the switches because they don't want to have VLAN 200 available in all three of these sites anymore. They're now going to put a router connected back to us, and they're going to manage and advertise their own network across that. So site 1 is going to have VLAN, have network 172.1.1.0/24. Site P on site 3 is going to have 172.21.2.0/24. And the site over here in site, actually, let's swap that around. So this is site 3. This is site 2. That makes more sense. So site 2, 172.21.2.0/24. Site 3, 172.21.3.0/24. And they are going to advertise those networks amongst their own 3 sites and manage all of their own connectivity. For us, nothing is going to change within our core network because we don't need to change anything. So let's jump onto our routers. So we'll start over here in V16 as the customer. We'll just call this hostname CE16. Now, the interface towards there is expecting a tag, so we're going to sub-interface that. So int G1 no shut in G1.200 encapsulation.200. We'll put an IP address. We will use the same IP address range, so 192.168.64.1/24, so 255.255.255.0. We'll no shut that sub interface. Int, let's do G2, which will be whichever's going down towards their switch. IP address 172.21.1.1, and we will no shut that. Let's do the basics of .17, which is the one up here. So config T, hostname, let's call this C17, int G1 no shut, int G1.200 encapsulation .1q, IP address 192.168.64.2, and the int G2 interface will be 172.21.2.1.255.255.255.0. No shut. Finally, the customer's last CE, hostname CE18, int G1 no shut, int G1.200 encapsulation .19200, IP address 192.168.64.3, 255.255.255.0. No shut. And int G2 172.21.3.1/24. IP address even 172.21.3.1.255.255.255.0. No shut. So obviously, if we go ping 172.21 2.1, that's obviously not going to work because we are not advertising any connectivity. But what we can do is let's test that the outside interfaces can all reach each other. So if we ping 192.168.64.2 from CE3, and we use the source interface of, or the source address of 192.168.64.3, we can see that we can reach that one. And if we try to reach one, we can see we can reach that one. So let's configure the customer's own routing protocol. So let's jump back over here to CE16. And we'll just do a simple OSPF setup. So router, OSPF1, and we will go to turn it on. I will set the router ID to 192.168.64.1, just so that we can see that it's definitely coming from here. We'll go into int G1 IP OSPF 1 area 0. Oh, sorry, int G1.200. It's a sub interface. Int G2. We'll advertise that one. Let's jump onto site 2. Router OSPF 1. Router ID 192.168.64.2. This is site 2. Int G1.200 for the sub interface. IP OSPF 1 area 0. Int G2. Advertise that network as well. Save that. And finally, CE7. Router OSPF 1. Router ID 192.168.64.3. Int G1.200. IP OSPF 1 area 0. Int G2 IP OSPF 1 area 0. Right, so we've received a full load. Let's have another look again. Okay, so there we go. We've got full, and we've got a BDR and a backup. So we can see from we're on CE 18 down here. We can see router 1 and 2. Show IP route again. There we go. We can see we've received the routes for these networks. So now from site 3, we should be able to ping 172.21.2.1, and we can. And we should be able to ping 172.21.1.1, and we can. So there we go. So now the customer has got complete control over routing between their sites. As the ISP core, we haven't had to change anything. So whether the customer wants to use it as a layer 2 service or do layer 3. So that's the flexibility there of using VPLS. Let's just do a quick Wireshark on one of these just to see what the traffic looks like if it's flowing from site 3 to site 1. So we'll do a capture on G4 on the P router, because it'll have to flow through here from gigabit 3 to gigabit 4. So we'll bring that up, and we can see we've got OSPF traffic flow flying across there. Let's send a ping from CE. We'll use source 172.21.3.1. And there we can see that the packet is being switched across the network via MPLS to make its way over to our other site. So if we send that continuously, we should see a whole lot of MPLS packets being switched through our core network between our two of our customer sites. And again, I'm just going to bring up PE4 now. As the customer is now a routed customer, as far as we're concerned, we still see those pseudo tunnels between the customer sites being signaled correctly. Let's have a look at the bridge. Show bridge domain 1000. Again, we can see new MAC addresses now being forwarded because obviously the outside interfaces of each of these routers are technically still within a single bridge domain. That's as if there's a virtual switch. As far as our customer is concerned, it's almost like there's a virtual switch sitting, i.e. virtual switch, VPLS, there's a virtual switch sitting in our core, and each one of these customers' CEs is connected to a port on that virtual switch. So there we go. One core network set up as a BGP free core. We made use of multi-protocol BGP. We have served 3 different customers across our core network there using 3 different types of technologies, giving the customer options and flexibility. We've given a customer a full layer 3 service site to site with which we then also had to then play a part in accepting routes from the customer, carrying them across our network and advertising them back again to the customer's next location. We then created a layer 2 customer connection using EVPN, and we created a site-to-site connection between our 2 customers' locations across our network for them. And again, we then created our 3rd customer and made use of VPLS to create a multi-point configuration so that the customer had the option to either have a single broadcast domain operating in multiple locations, or to create and manage their own routed network across that service without us as the core network operator having to get involved in any of their routing. It was all maintained and controlled by the customer. So I hope you can see how all 3 of those worked. I hope you understood that. I hope you enjoyed it. If you did, please do hit that like and subscribe. I think we're getting very close now to 1,000 subscribers. It'd be great if we can finally hit that goal. And big thanks to everybody who has liked and subscribed so far. Like I said, I start a new job in the coming days, so I'm going to be kind of busy for a little while, but I'm going to try and at least get 1 content video up at least every 1 or 2 weeks, so that there's something for you to enjoy or something that I can demonstrate for you. So until the next video, I'll see you next time. Have a good one.